Hey, Darcy.
Okay, thanks everyone. Welcome to Mesa's overview of IEEE 1815.2. I'm Darcy Wheelis. I'm the Executive Director of the Mesa Standards Alliance. I'm also joined by Francis Cleveland, who is a long-term Mesa technical consultant, and Tyler Slay of PNNL. We're gonna, as I mentioned before, we're using a new format for these as webinar format. So bear with us if we have a technical slowdown every now and then, but we think we have it figured out. And feel free to type your questions into the question and answer portion, and we will try to answer those live. We will also try and leave some time at the end for questions and answers. So I want to go ahead and okay, let me share my screen. All right. And just a quick check, can you all see the PowerPoint presentation?
I'm
I
not in
see.
presentation
Yeah,
mode.
not in presentation mode.
Okay, oops, okay. There we go.
Good.
All right, how's that? All right, so we're here to talk about 1815.2. Give you a little bit of background on Mesa and where 1815.2 came from. Francis is going to dive into some of the technical aspects of the new standard, and then Tyler will jump into a little bit on our testing and certification program. I'll tell you a little bit more about how to join Mesa and get involved and get technical assistance if you're trying to implement 1815.2. We also
Oh,
have a couple more
you need to
upcoming
switch the
webinars.
screens again.
Oh, I do? Thank you. There we go. Okay. Um, and then we have some upcoming webinars that dive into the more details. I'll touch on those at the end. Quickly, for those of you who don't know us, Mesa is a group of utilities and technology providers and vendors who come together to make distributed energy communications more interoperable. That's essentially what we do. Our mission is to accelerate the implementation of DERs and using by streamlining communications and by using well-established standards. So we don't want to create something new. We're really trying to build on what has been out there before. Where do we work? Well, in between where their SCADA, your utility control systems, talk to DERs or IBRs or microgrids, that's the space. And where those DMP3 communications, and where those communications are using the DMP3 protocol, that's where we've been focusing the majority of our time. And it used to be called Mesa DER. We've now updated it because it has been incorporated into 1815.2. We also do some work with SunSpec on Modbus for the components of an energy storage system, but we're focusing on our DMP3 work today. So where does IEEE 1815.2 fit? This is a complicated slide, but I just want you to focus on where we have the orange circles, and you can see all the different layers in this in the DER world where you can use 1815.2. And if you come to other presentations, this is Francis's slide. She can go through this in a lot more detail if you have questions about where to use it. There's also a users group presentation that talks about when to use the different protocols in 1547. DMP3 being one of them. So if you need those resources, just reach out, or if you actually look on the email that you receive from us, there's a link to previous Mesa sessions and the DMP3 users group session. Okay, so what is 1815.2 and why do we need yet another standard? So it's a communications profile for DMP3, and it basically helps for if you're trying to talk to DERs, IBRs, or microgrids, you want to use this. And most utilities use DMP3 for their communications. So that's why we focused on, Mesa's focused their work on the DMP3 protocol. And why do we need another standard? Because there's a lot of DERs out there. And interoperability will make it easier for utilities to integrate these products and talk to all these different devices. And it's easier for manufacturers to build if they have a standard. It also can provide cybersecurity. And one of the also really important things is full scheduling capabilities. And Francis will dive into this a little bit more. 1547 has some basic capabilities, and 1815.2 expands upon them. Some additional high points of 1815.2, it really builds on what was previously out there. It has the data objects needed for DER, IBR, and microgrids. Again, including the ones from 1547 and 2800, as well as the specific and additional functions that you need for storage systems and other controllable loads. And again, these are all based on data objects from 61850. We're not reinventing the wheel here. It also has detailed data objects for DER meters, DER units, inverters, etc. I mean, we've really tried to cover our bases. We also have a normative spreadsheet that you can download from the IEEE website, and that really helps you have a spreadsheet that you can download, so it helps implementation. You have your points list right there. It remains backward compatible with the MP3 application note. So if you had spent some time using that application note that was released in 2018, you're good. And since that application note was released, there's a lot of improvements. Then those have all been incorporated into 1815.2. Here's a graphic description of what I was covering. We started with the 1547 functions. We added in the 61850 semantics. We have MESA's deep work and the MESA DER specification and spreadsheet, which includes a lot of additional functions. We added in the app note, which MESA worked on with the DMP users group. You wrap those all up and you have 1815.2. So again, lots of building off of lots of existing work. And I want to touch on those functions briefly. You can see on the left, those are the 1547 and the Rule 21 functions. I'm not going to go through all of them. I just want to highlight that if you look at what 1815.2 has in it, all these additional functions that MESA created and were part of the MESA DER spec are all now in 1815.2. So there's a lot more here, a lot more useful. So why do you want to do this? It's an international standard. It's been vetted. A lot of experts have looked at this. It clarifies expectations for projects. So utilities can point to it, vendors can build to it, and MESA's supporting it. We have technical support available. We're going to have a technical issues process when people have suggestions or if they have typos or anything. We are going to be managing those, and we are going to be developing a formal testing and certification program, which Tyler will touch on shortly. Using this standard communication profile will reduce time for implementing DERs. It's basically the same way utilities treat substations and communications with SCADA. So we have a standard there, we should have a standard here. Also, as I mentioned before, it's pointing to other standards. So it's not creating something brand new. And if you're moving to 61850 down the road, you already have the points list with the names that are directly taken from 61850. From here, I want to hand it over to Francis. And Francis, if you can get control of those slides, otherwise I'm happy to manage them for you.
Yes. Let's see. I can request control if I remember, or you can pass me control. So I'm requesting it. We're still learning this new
when I'm in slideshow mode,
technology.
I can't assign it, so you have to request. So there you go. You should have it now.
Okay. Oops. All right. I'm going to start here with the actual document, which is because 1815.2 is actually split into two pieces. One is a Word document, a PDF type document, and the other is an actual spreadsheet, an Excel spreadsheet. Um, so, because the spreadsheet was really important to allow electronic access to the data points rather than trying to manage them all in a Word document, which is not known for its ease of access of data points. So, the data points themselves are all in a spreadsheet. But in the Word document or the PDF document, which is what you would get, you can see that we have all of the functions. These were obviously first the 1547 functions, but in addition, the additional functions for storage, microgrids, and data loads, controllable loads, which we know is coming but is not yet in 1547. So we have first just a table showing here that we have the different functions on the left, a brief description, the clauses either in a table or the clauses that describe the function in more detail in the document itself. And then we show the spreadsheet point range where it's located in the spreadsheet. So you can see we have a comprehensive way of trying to manage the two elements, the document plus the spreadsheet, trying to keep them all in sync, which hasn't always been easy. And Darcy mentioned the technical issues process that we are developing, we have developed already. So that if there are errors or there are updates or even clarifications to something, we can put that into this technical issues or tissues process so that it can be captured, reviewed, and whatever updates need to be done can be made. Okay. Um, all right. It takes a while for it all to work. Okay, so here is the spreadsheet as an example. This is the configuration binary outputs where it shows, I'll click once and hopefully, yeah, there it is. The DNP3 points off to the left, and as you can see, BO means binary output. So it just goes from BO0, BO1, BO2. So these are just DNP3 points in sequence. And then the other highlighted area or circled area is the IEEE 61850 unique string. So we have kept the names from 61850. We don't keep the data structure from 61850 because that's fairly complex and is not directly compatible with DNP3. There is a way to do that, but we decided to go just with straight mapping of the names to the data points. So the name here comes in the middle box, comes from 61850. The data point is just the DNP3 data point. We also have additional information in the spreadsheet, the status, the associated binary input point, purpose, 1547, whether it's required there or not, and there are a few other columns with additional data. This is the same for analog inputs. Again, the DNP3 point with analog inputs 0, 1, 2, 3, so forth, and the 61850 names. As you can see here, we have additional information like the scaling factor, as well as the maximum and minimum of a transmitted value, so you can do error checking, etc. And again, the additional information and whether it is required by 1547. So the next thing is I'm just going to get in at a fairly high level some of the functions so that you can see how they would work. So one of the more interesting, or rather more important functions, as we've discovered, is the active power limiting function. Now, in 1547, active power limiting really just means limiting the export of power. 1547 is being revised, and I believe will also include limiting the import of power. But we've already developed, oops, how did that happen? Um, we've already developed the ability to actively limit export power and import power. So what I'm showing here is the spreadsheet up at the top, which shows the functions and the DNP3 points and the 61850 names, plus the additional information. In the document itself, in the 1815.2 document, PDF, we have gone through and described step by step what you need to set in order for the function to be activated. And so you can see here, now many of the, whether the step may be optional if you've already set something. You don't have to reset everything all the time. But these are the steps that you need to take at least initially. Then some of it is required, like setting the maximum output percentage and then enabling the function. And then, as you can see over on the bottom right, this would be the responses. So it could be just limiting the generation, but there can be a limit to the generation and also a minimum requirement for some export. So you can see it actually could require the export to be bound by a sort of a bandwidth of requirements. The same is true for, we call it charging, or we can call it consumption, or we can call it import. So you can limit the import charging or consumption as well. Or you can have a range that just says, okay, there's a limit to the generation export and there's a limit to the import generation, but no minimum requirements for import or export. So that's this third diagram. Peak power limiting and load following, generation following, are also some of the more complex, conceptually complex, not complex from a communications perspective, but complex in terms of what you would like the system to actually do. And peak power limiting, which is very similar to load following, it's got some minor differences, basically says, okay, let's make sure that the load, the maximum import or the load, is limited by using generation to counteract the load or to feed the load, if you will, internally or even externally. So it depends upon where this limit is supposed to apply. In 1547, it's the reference point of applicability. But we have the ability to set these parameters. The same thing is true with generation, so that you can follow generation and make sure that the export is limited by using, say, the additional generation from the solar to charge up storage. I think some of the transmission companies like CalISO, well, not transmission, but balancing authorities like CalISO would need this in the middle of hot days where there's just too much solar. you might as well be able to charge your storage or use it for loads, maybe data centers specifically. Um, and so this would be a function that you would use to manage that. Uh, then we have a more common function, which is the droop function. Um, it looks like there are a lot of steps for this, and that's because the frequency watt can be more than droop. I won't go into the details here, um, but we have provided the droop function as defined by 1547. We've also made it a little easier to use than is specified in 1547. But we've also allowed for other types of um, measurements of frequency having the active power respond to that frequency. So not just droop. And I think, yes, so we have, for as an example here, we have the advanced, what we've called advanced, it's just really different frequency watt that meets the European requirements rather than the droop requirements that are in 1547. So these are some functions that could be used, again, with the frequency watt capabilities, so that you can have more than just droop. You can have managing where exactly the function applies, where it doesn't, how it ramps back up to being in normal situations. So there's a lot of power to these functions. Okay, we also have started with some experimental functions. These are functions that have not yet really gotten well defined as to exactly what they should be doing. So we didn't feel comfortable making specific requirements, specific, here's how you do it, because we're communications. We're really there just to communicate the capabilities or the requirements. We're not there to define the requirements. But one of the areas that has been of great interest is synthetic inertia, which is really using the rate of change of frequency, the Rokoff, to change how the system then responds. So we have put in an experimental version of synthetic inertia, but we have kept it as experimental so that no one feels that they would ever have to implement it exactly as it's defined here. And over time, and I mentioned the tissue process, the technical issues process, this is where we expect to get input to say, hey, we would really prefer to do synthetic inertia or artificial inertia like this, or here's some areas where, we'd want a deadband or, some other things that are not in this particular version of synthetic inertia. So we're still waiting for some of these really more complex functions to be defined elsewhere, and then we will pick up and define the communications requirements for them. Okay, scheduling. Scheduling has become one of the more interesting and necessary functions. In California, in specific, there is now an ongoing effort by the California Public Utilities Commission to define exactly what is needed, but it's clear that limits are going to be needed not only for export, but as data centers, for AI and other Bitcoin operations, whatever, that and charging EVs. I have a newly installed heat pump, so that's now a controllable load. So all of these controllable loads should be able to be limited if needed, as needed. So uh, there's a concept of having firm limits, but firm limits have to be defined, you know, months, years ahead. And as everybody knows, that doesn't make it for very real. It might be very over restrictive to be limited by something you've designed a year ahead. So California is now looking at non-firm capacity limits that would be updated on a monthly, weekly, daily, even hourly basis so that they could be managed much more dynamically, much more flexibly. Um, so this is also being developed by UL 3141 for scheduling limits and import limits. So again, both the export and import. Okay, so now we have this concept of limits, and particularly if they're going to vary during the day, during the week, during the year, during the month, you need some form of scheduling. So this is where uh, using an example that California has been initially working on, which is the limited generation profile, using that for firm and non-firm export example. Of course, the same would be true for import. And as you can see here, the firm export would be something defined maybe ahead of time or during the time when an agreement is made. And so because that's what they know, what the utility knows, 2 years ahead of time, it should be like this. But the reality is really this blue line, which says the reality is much different from the red line. So you could have the purple arrow says, okay, the limits really can increase at this point. It doesn't have to be limited to the red line. And up here can be, again, anytime you have the blue line going above the red line, you actually could increase your export capability, but you need a schedule to do that. And so we have developed, I won't go into the gory details of this because that can be a little on the detail side, but one of the other sessions that we have can go into it in more detail. We have developed a complete scheduling capability. We call it using the selector mechanism because DNP3 has, a limited number of data points, and every data point has a number, not a name. Now, we've assigned names to most of the data points, or some of the, every data point that we've identified has a name on it. But if you have scheduling capabilities, what you want is to have each schedule have a select set of names. So that's what we've done. But then we have schedule number 1 gets stored away. Schedule number 2 comes in the same DNP3 points. Those can get updated and then stored away somewhere. We're not saying where the schedules get stored, but the point is we reuse the same DNP3 space for scheduling so that multiple schedules, 200, 300, there's no real practical, there's no real limit. It's only practical of what you can store. So we do have this scheduling capability that allows different functions to be scheduled. So not just power limiting, import or export power limiting, but any function, volt var control, frequency watt control for different times of the day, different minutes, different seconds even, different hours, different weeks, different years, even. So we've got this full scheduling capability to do all of that. So I'll leave the details to how this all functions to when we do a deeper dive into the functions themselves. But for now, I will pass this off to Tyler, and I think, Darcy, you can pick up on it.
There you go.
All right. Let's see. Give me movement. There we go. All right. So I wanted to keep this first slide pretty bare to just go over the kind of three major components of the testing process. So we start with semantic testing. Semantic testing says, do you understand the relationship with your data? Can you load in the PICS sheet? Can you configure your device? Does your device understand what the AO, the BO, and how they relate to the AI and BI? Are you able to multiplex the curves and so on? So once you've interpreted that data and you want to be able to also, when you receive a write command from your DMP3 control station to one of your AO points, you want to make sure that it's going to update the AI, the corresponding AI, and also generate the proper events if it depending on the event class that that point was configured as. And then when you use one of the selectors, as Francis was talking about, to manipulate the multiplex schedules or the multiplex curves, is it actually loading in those backend points that are stored in some external data source correctly, and they are maintaining the map. And then the final, are you enforcing all the bounds that were defined in your PICS? So you have your minimum and maximums for your various points. You have the scaling factors. Are you multiplying the scaling and offsetting your scaling from your transmitted to engineering values properly, both reading and writing back and forth? Then you get into the functional testing, and this is where Francis described all of the actual response to that the grid wants. Are you maintaining the actual setting at your reference of applicability? So this is where we take all the functions defined in slide 11, which is the 21 functions, and we go through each of those. This has to be in a very controlled environment for a device. So we hook it up at a nerdle and they can connect to all the inputs and outputs and have a controlled input where they're manipulating what the grid would be and they get to actually see what things are happening. And then you get to the final stage, which is commissioning. This is where you're in the field. It's most likely a large plant, a large control system where you can't bring it into a nerdle and have it tested. So you go out to the field. You're going to be working with yeah, a lot of different utilities. You're working with your interconnection agreements that are defined by balancing areas. So it's a lot more complex of a task. Next slide, we'll see. Wow, there we go. Very laggy. So getting into the more details. So the semantic tests, they require the passing our test tool. It's not just our test tool. We're just the first ones that are having a tool available. There's other manufacturers, Triangle Microworks or Quality Logic Sunspec, if they come up with a test tool, as long as we've looked through it and it jives with the nerdles, then that works just as well. But it just requires going through some process first to understand that your device is ready to be tested for a functional use case. And then we obviously recommend going through the actual protocol, DMP3, through the DMP3 user group and their cybersecurity certification for your actual device semantic tests. Then you get into the functional tests. This is you need to have that semantics done, And then this is where we tie into the 1547, 1741 SB testing that's already predefined. 1815.2 is a superset of 1547 UL 7041 SB. So all of the requirements that are there are still required in 1815.2. If you pass all of those, then you become certified for 1547. And then when we release the additional 1815.2 functions that are also outlined on the right-hand side of slide 11, where you have all the 21 functions, then you would become 1547 compliant and 1815.2. And then you get into the commissioning. This is your factory acceptance testing. You're going to go through all of the same steps, but you also have to factor in whatever your interconnection agreements, your utilities requirements, your site restrictions. Those all have to be factored in, and it's not a one-stop shop defined standard. It's going to be very specific to individual implementations. And there we go. The base certification entities. So we have our DNP3 user groups. That's where you're going to get your protocol and cybersecurity certificate. They're the only ones that offer that currently. The 1815.2 semantic will come from one of the manufacturers, starting with our test tool, but eventually I'm sure there's going to be others that are available. We know the industry has a lot of engagement, so we'll definitely see some other players come around. The 1547.1 UL, that's going to be any NRDL. Particularly, we're working with UL, but it's not restricted to UL. It's just that's our main NRDL. And then when you get into the commissioning, again, it's not going to be a one-stop shop. It's going to be the series, DNP3 user group, P&L's tool, UL, and then whatever else is added on top of those three.
Tyler, we have a question. I don't know if
Yeah.
you have your questions up, but just about the functional testing and how it is done. If you use power hardware in the loop kind of power system simulation, or if you just test the given input matches with a pre-verified output.
No, it is hardware in the loop. UL, I don't know if they have any publications specifically, but they do have hardware in the loop setups. You bring in your device, you connect it up to their hardware. They have grid simulators, they have their meters, they have everything. So they can very specifically set up what your device is going to observe and how it's going to respond to those grid events. So you can test those mandatory trips, those ride through settings. You can test your frequency watt volt var functions. All of that can be handled in a very structured manner.
Thanks, Tyler.
And I'll pass off the rest to Darcy.
Okay, give me 1 second. All right. Let's see. Oops, I have to go back one. I wanted to talk a little bit about the test tool and also the time. I realized we didn't touch on the timing. I'll just go back here real quick. We're calling this phase 1, the semantic testing. We're going to be rolling that out later this spring, maybe early summer, but we're very close. We're going to be beta testing any day now. And once we feel like we have that test tool where it needs to be, and we've had a few MESA members go through the process, then we'll open it up, and that will be available through UL. And the functional testing is something that we're working on. We're hoping maybe end of the year we'll be able to start beta testing that and roll it out shortly thereafter. Commissioning, again, I think that's further down the road. We're working actively on creating these programs. If you want to help create them, please join MESA. What I did want to do is provide a quick screenshot of the test tool. This is the screenshot of the scheduling function, just to give you a sense of what the user interface looks like. We're going to have in May, we're going to have a deep dive into the um, semantics, this phase one testing, and do a demo of the test tool. So never fear, it's coming. Again, if you want to get involved, if you want to do beta testing, if you want to have more input into how this is developed, reach out to us. And you do that by becoming a Mesa member. Again, some of the benefits is you get access to the 1815.2 standard. You don't have to pay for it. Mesa, the DMP3 users group, and the IEEE all share intellectual property. Mesa members and DMP3 users group members have access to the standard for free. And again, you get to shape how this evolves. This is just the first version of this standard. There are several issues that were left on the cutting room floor, so to speak, and that would need to be addressed. We are not going to wait 6 years to update 1815.2. We may open a PAR within the year and start working on updates. So we're collecting the technical issues, we're collecting the corrections. We want to get lessons learned from the field and incorporate them quickly. You'll also have access to the experts who are help creating the standard and this testing and certification program. You're going to get lessons learned. There's Mesa members who've been working on this for a decade. They've been taking previous versions of 1815.2 and implementing it in the field. You get access to them. We will have regular meetings. We want to start up an implementation work group. We also have a technical work group that will work on the standards update. If you need help, you get 5 hours of technical assistance with your membership. So what does it cost? It's about 5K for most folks. And then a lot of utilities and some vendors also make a discretionary technical allocation. Our member fees do not cover our costs. We rely on folks to give us extra hits. Usually those come from R&D and not membership budgets. So if you're able to do that, it's really helpful for Mesa to help us continue our work. The more resources we have, the faster we can move things along. Also wanted to give you a quick hit on our upcoming presentations. April 28th, as Frances mentioned, she'll be doing a deep dive on the 1815.2 functions. Then in May 19th, as I mentioned, that will be more information on the test tool, on the testing and certification program, and a demo. If you want more information, this is how you find us. We will be sending the presentation around and the recording, so look for that. It just takes us a minute to get it all bundled up, but we will shoot that out to you. There are also previous sessions. All of these recordings are posted on Mesa's YouTube channel, and so we will post this as well, and the future sessions. If you can't make one of those sessions, never fear, we can schedule one. Or we can schedule one, or you can review the one on the Mesa website. So does anyone have questions? Let's see, I see one in the chat. Is there any work going on to convert these Excel files to machine readables like JSON or XML? Tyler, do you want to take that?
Yeah, that that is specifically what the tool does inherently. You can load in the original PICS spreadsheet. That was the assumed use case, was that's the starting point for most people. But it gets converted to JSON, and the update when we make the next update, JSON will become the standard distribution of the picks. It allows for not only definition of all the same points in a very an easier manner for computers to load in than a spreadsheet, but it also allows you to save in curves and schedules, which again are multiplexed, and the spreadsheet doesn't really handle that very easily. So you really have to rely on a separate way of getting those curves in. Our tool, it does have all of the individual editing ability for all the points, as well as you saw, the ability to create schedules and have those all loaded into your PICS profile that you will then load into your outstation or control station.
Great. Other questions? Feel free to raise your hand or type them in the chat.
So I might just add one thing on the JSON front, which is that 61850 which of course is where the names and purpose of the data points comes from, is also going to be utilizing JSON, uh, or can be at least converted to JSON as well. So in the future, I think we're all going to be working much more closely together so that there won't be so much copy and paste. And let's hope that it doesn't change over time. So I think working with all of these data points in JSON is going to be a great help in the future.
Okay.
Is there any JavaScript in the tool, in some of the front end? Just because it is a web portal for like accessing the front end of the tool, but that's about it.
Great. Other questions for this afternoon? I guess it's still morning from us on the West Coast. Okay, with that, I hope to see many of you at future sessions. Feel free to reach out if you have any additional questions, and I hope to hear from some of you and see more of you in Mesa's work group meetings. Thanks, everyone.
Okay, bye.
Bye.